Hi there. Today I'm going to be going through question 4 of the DBE November 2021 Mathematics Paper 1 past paper. This will be quite a short video because I'm only going through this question. All right, so for this question, we are considering a linear pattern 5, 7, 9. Okay, so it's a linear pattern. Okay, so we're going to do the first question, which asks us to determine T51. Now, it's obvious here that we can't, it will take us a very long time to keep adding the constant difference to try and find T51. So we need to find the general term that is Tn, the formula for the sequence, and then substitute n is equal to 51 into this formula. Okay, so the formula of the general term for linear sequence is given by a plus n minus 1 times d. Okay, so I'm going to copy that down. Okay, now a is my first term, which is 5. D is equal to T2 minus T1 or T3 minus T2. It's the constant difference between our terms. We can see immediately that this difference is 2, but let's just formally calculate it. 7 minus 5 is 2, and 9 minus 7 is also 2. So I'm going to substitute in 2 in the place of D, and then I'm going to distribute this 2 into the bracket. And so I get that 5 plus 2n, I get 5 plus 2n minus 1, which simplifies to 2n plus 4. So then I'm not done yet because I need to calculate T51. I simply substitute 51 in the place of n. And if you plug that into your calculator, you will get 2 times 51 is 102, plus 4 is 106. All right, so that question is now done. Now, for the next one, we need to calculate the sum of the first 51 terms. So now we need to use the formula for the sum of an arithmetic or linear sequence. And that is given by Sn is equal to n over 2 multiplied by 2a plus n minus 1 times d. Remember that when we calculate the general term, we want to calculate the value of a term at some position, we use Tn. And if we want to calculate the sum up to some position, we use Sn. Okay, so let's copy that down. 2n multiplied by 2a plus n minus 1 times d. So we want the sum of the first 51 terms. So I say S51 is equal to, or let me just write it in general. First, Sn is equal to n over 2 multiplied by 2a plus n minus 1 times d. We must always go and check if we've written down the formula correctly, because it would be very bad to mess that part up. Okay, so now we want to calculate it for S51 specifically, because we want the sum up until the first 51 terms. So we substitute 51 in the place of n. Okay, 51 over 2 times 2a. A is equal to the first term, which is 5, plus n minus 1. So 51 minus 1 times d, which we know is 2. Okay, you can plug the whole thing into the calculator, but I'm just going to simplify the bracket first. 2 times 5 is 10. 51 minus 1 is 50 times 2 is 100. So it's 51 over 2 times 10 plus 100. If I type that into my calculator, 51 over 2 multiplied by 10 plus 100, I get an answer of 2,805. And that is how you calculate the sum of an arithmetic or linear sequence, or you evaluate the series, a linear series, up to term 51. That's another way they can word it. All right. So now they want us to write down the expansion of sigma from n equal to 1 to 5,000 of 2n plus 3. Okay, so sigma is just a fancy way of saying take the sum from the bottom, oh, sorry, not I, we're using n here, from the first position to the 5,000th position. And then what you put in the brackets, it's like you're telling the sum, I want you to take the sum of a series where the values are determined by the formula 2n plus 3. Okay, so for this question, we actually only have to write down the first 3 terms and the last term of the expansion. Okay, so this is going to be equal to the sum of all these individual terms. Okay, now a first instinct, is this formula the same as the general term for our sequence we were just considering? No, it is not. That is 2n plus 4. Now we are dealing with 2n plus 3, but it's fine. To calculate the first term in this series or sum, do you agree that's going to be for n is equal to 1? So to calculate this first term, I'm going to substitute 1 into the formula. 2 times n, which in this case is 1, plus 3. Okay. Then I need to do the first 3 terms. So I say plus the next one is going to be at position 2. So I put 2 in the place of n in the formula. And then I'm going to say, I'm just going to write down here, plus, now we're in the third position. So we are going to use 3. Then we don't have to show all the middle terms. We only have to show the last term. So what we do is we put 3 little dots in between 2 plus signs to like indicate that there's lots of terms in between. And now we need to calculate the last term, which is for n is equal to 5,000. So I just substitute 5,000 into the formula. Plus 3. Now I want to simplify this because it doesn't look nice. Okay, so 2 times 1 is 2, plus 3 is 5. Okay. 2 times 2 is 4, plus 3 is 7. Plus 2 times 3 is 6, plus 3 is 9. And then, okay, now in this last term, 2 times 5,000 is 10,000, plus 3 is 10,000 and 3. Okay, so that's that question done. I hope you understand how this sigma works. Just saying we must take the sum from position n is equal to 1 to 5,000 of tn plus 3. This would be equivalent to me saying S 5,000, where I tell you that Tn is, so we need to calculate this if Tn is equal to 2n plus 3. I hope that makes sense. All right, now the next question. Hence or otherwise calculate the sum of n from n is equal to 1 to 5,000 of 2n plus 3, that a sequence with that formula, plus the sum from n is equal to 1 to 4,999, where the formula is minus 2n minus 1. Just a warning, they love asking this question. And so in this question, it would take you a very long time to calculate these sums. And they've also said hence. And whenever they use hence in a maths paper, it means that you must use what you have just figured out. And do you agree we actually just found an expansion for this. So I'm thinking we need to use that expansion again. Just another hint. Whenever they ask you to add two sigma expressions together, what you should do is actually expand each sigma or sum and show like the first three terms and maybe the last one or two terms. And you will see the magic that happens. This question comes up a lot, and I promise this is 99% of the time the way that you need to handle this question. So we are going to say the sum from n is equal to 1 to 5,000 of 2n plus 3. And then is that a plus or a minus? Plus the sum from n is equal to 1 to 4,999 of minus 2n minus 1. Okay, so I just want to check what was our original sequence. That did not have a general term. No, our original sequence had a general term of tn plus 4. So we're not going to be using that at all. We're disregarding that original sequence. Okay, so what you're going to do is we're first going to expand the first sigma. And I'm actually going to write that in pink. We did that above, so I'm literally just going to copy down what we had there, which was 5 plus 7 plus 9 plus 10,003. So 5 plus 7 plus 9 plus plus 10,003. And then I also like to put brackets around each sigma's expansion, because then I can keep track of which sum is which. Okay, let me go and do the second sigma now. Okay, and I always like to write the next sigma's expansion on a new line as well. Okay, plus, let me just keep that same blue going. Okay, plus, now I'm going to need to expand this. So I'm going to have to calculate the value of this expression at each n. So I start at n is equal to 1. And I must calculate, so I'm going to put like a curly bracket around this one because I'm going to have lots of little brackets. Minus 2 times n, which is 1 in that case, minus 1, plus minus 2 times 2, because we're in the second position, minus 1, plus minus 2 times 3, minus 1, plus, and then dot, plus, now I must calculate the value at position 4,999. Okay, minus 1. So now what I want to do is I want to simplify these expressions, because they're all simplified in the first sigma expression. So I want to simplify it nicely. Okay, minus 2 times 1 is minus 2, minus 1 is minus 3. So I'm just going to write minus 3 here. Okay, then in the second one, minus 2 times 2 is minus 4. Minus 4 minus 1 is minus 5. So now it's minus 3 minus 5. Okay, then we have minus 2 times 3, which is minus 6, minus 1, which is minus 7. Okay. And then we have plus and a bunch of dots. And well, it's actually quite clear that these pluses will be minuses, but we can just write plus anyway. Now, minus 2 times 4,999 is negative 9,998 minus 1 is minus 9,999. Okay. Now, next thing, what always happens with these crazy sigma expressions when you add two sigmas together is you will see a pattern form between the two expressions. And do you see that this term over here, let me use some purple, this minus 5 will get rid of that 5 over there. And this minus 7 will get rid of this plus 7 over there. And this pattern here, the next term will be minus 9. And it's going to keep subtracting from this expression above. So all of these terms are going to cancel. Now I see that this one ends on a minus 999. And this one ends on a positive 10,003. So I actually want to expand the first one a little bit more, see what the like second last, third last terms are. Okay. So I guess I can do it in a new line. So I've got rid of a lot of things. Or actually, let me rather do it on top here. So I'm going to move over this 10,003. Okay, so let me move it over here. And I have a feeling I want to start like with the third last one. Okay. I just want to see if this 999 appears. Okay, so if I go back to the formula, it's 2n plus 3. So if I have, so the last term is the 5,000th term. So I want to calculate the 4,999th term and the 4,998th terms. Okay, so I'm going to start with the 4,998th term. And for that, I need to calculate 2 times 4,998 plus 3. 2 times 4,998 is 996 plus 3 gives me a value of 9,999. So I can see that this last term here will cancel out this term. But what is my 4,999th term? Well, 2 times 4,999 plus 3 gives me 10,001. Okay, and I got this by substituting 4,999 in the place of n into this formula. So I see, so after you've done all of your canceling, because you realize there were patterns in these sums, we need to go and look which terms are still left behind. Well, it's minus 3 here because that didn't cancel with any other term. This 1,001 didn't cancel with any other term. Sorry, it's a 10,001. Didn't cancel with any other term, and neither did this 10,003. So my sum is now equal to 10,001 plus 10,003 minus 3. And this is going to be equal to 10,001 plus 10,000, because this 3 subtracted by that 3. So it's 10,001 plus 10,000 is equal to 20,001. And that is how you do this question. I know it might seem a little bit difficult to identify these patterns that I've done here, but this question does come up a lot in past papers. So I recommend looking through some past papers and practicing questions like this, and you will start to get the hang of it. Just remember that when you see two sums being added together, there will be some kind of trick, like I've shown you today, where you expand the first 3 terms of each sequence and maybe the last 2, and then do the same for the other series or sum, whatever, and then look for a pattern and see which terms cancel each other out, circle the ones that aren't canceled, and add those together. I promise you that that is 99% of the time, that is the form that this question takes. And as it does come up a lot, it's definitely worth practicing and learning this. I hope that you found this video helpful, and sorry that it was such a short one.